Hi, it's time for another math easy solution. Trying to discuss further into integrals and areas between curves and solve basically another example. I'm going to go over part 2 of the example series and solve this example to help illustrate integrals and areas between curves. Basically, the example states find the approximate area of the region bounded by the curves y equals x divided by square root x squared plus 1 and y equals x to the power of 4 minus x right here. Now, like I showed in my earlier earlier video on examples part 1, to basically to find out where these are bounded, we would have to find at which point these two curves intersect, and to do that we would have to do equate them and find for which x values are both functions equal. So we'd have to equate them. So we go x divided by square root x squared plus 1 equals x4 minus x. As you can see, these are complex equations, and solving for x is actually very hard. In fact, it is impossible to get the exact number. So impossible to solve this without just some sort of approximation technique. But in our case, we could basically just use a graphing calculator. Yeah, so if we were to use a graphing calculator like I've done over here, I just copy and paste it. If you just type in Google equation x divided by square root x squared plus 1 and x to the power of 4 minus x, as you can see, you have the two functions and where do they intersect. So at this point it's about x equals 0, and this point right here, it's, well, this point, which is about x is approximately 1.18. So we could just use these two values, x0 and x 1.18. So it's roughly that, and it's close enough for our example, and we can find this is the area bounded, basically we'll call this A, by these two curves right here, and the blue is this one and the red is over here. Yeah, so now if you were to set up the integral, it would just be integral of basically from 0 to 1.18, or roughly 1.18, and then this is going to be of the top function x divided by square root x squared plus 1 minus, now this is going to be minus, again this is all in one integral of x4 minus x right here, and then dx. Yeah, so basically we have this a standard integral right here, but this one here we'll have to solve it actually using substitution rule, and I'll basically then the best way of doing this is just break these into two integrals. So this equals to 0 1.18 x square root x squared plus 1 minus, and then dx right here, minus 0 1.18 of x to the power 4 minus x dx. So now we'll just try to solve this first, this one right here, and we used substitution. Yeah, and in this case we want to simplify this, and the best way to do that is just make this just simplify the inner function of the square root right here. So we'll let u equals 2x squared plus 1. So when we do that, now we know du, take the derivative, is equal to, now we'll have 2x dx right here. So we solve it, we'll have dx is equal to du over 2x, and we also have these 2 points at x equals 1.18. u is equal to, well, this one right here is going to be 1.18 squared plus 1, and this is roughly 2.39. Yeah, and you can plug that into the calculator and you should get something like that. And now at x equals 0, we have u is equal to, well, 0 plus 1, 0 squared plus 1, that just equals to 1. So we have all these. We could put these inside this function, so we get basically integral from 0 to, not 0, we'll have it from 1 to 2.39 of, now we have, there's an x dx right there. Yeah, and in fact, actually it's better writing this one right here as du over 2 equals x dx right here. So we can just replace that whole top line. So we'll have now right here is just going to be, well, du over 2. So let's put the 1 over 2 right here. That says du over 2 equals x dx. Now we've replaced that, and then it's just going to be, well, 1 divided by square root u right there. So we have this part right here, and this one, if you just solve integrals, I'll simplify it a bit further. 2.39, 1 over 2. This u it could be also written as a power of u to the power of 1 over negative 2. 1 over negative 1 over 2. Yeah, I mean u to the power of negative 1 over 2. And now when we solve the integral of this, we'll have 2.39. This is going to be, well, actually, yeah, I should have written that bracket. But anyways, we'll write it like this. It's going to be 1 over 2. Now the integral of this, we have to add 1 on the power. So that's going to be negative 1 over 2 plus 1. That's just going to be 1 over 2. And now we have to divide by this power, which is divided 1 over 2, or multiply by 2 right here. So these cancel right there, and it's from 1 to 2.39. These cancel, and we're basically left with this equals to square root 2.39 minus, so that's this one, I plug in the 1, minus square root 1, or equals to square root 2.39 minus 1 right here. Yeah, so now we've solved the first part of the area integral problem. Now we need to just solve this one right here, which is more straightforward. So we go area is equal to, actually let's write this, the first part, 2.39 minus 1, and now this is minus integral of 0 to 1.18 x to the 4 minus x dx. And now we could easily solve that integral. 2.39 right here, minus 1, minus, put in bracket, x to the power 5. So we add a power, and then we divide it by this power 5, minus x squared over 2. Now this is from 0 to 1.8. So this is the full final answer is going to be square root 2.39 minus 1 minus, now we just plug in 1.18 power of 5 divided by 5 minus 1.18 power of 2 divided by 2, and then we also subtract by, well, 0. That just plug in 0, it's going to be 0, so we can ignore that. Yeah, so basically this is, plug this all into the calculator, and we get approximately 0.785 as the area. Anyways, that is yeah, that's pretty much, that's the answer. Anyways, that's all for today. Hopefully you learned from this example. It's a bit intensive, but it's pretty good because it shows you that even if you can't find the exact number, you could just approximate where they intersect by graphing it and zooming in, and basically there is our number there. Anyways, that's all for today. Hopefully you learned from this video. And like always, you can download these exact notes in the link below in the description. And thanks for watching, and stay tuned for another Math Easy solution.